Hello, good morning, everyone. So yesterday,
Morning, sir.
Good morning, Jitendra.
good morning.
Morning, all.
Yesterday we had discussed with GRE. So let us quickly recap. So generic, routing, encapsulation. So it is a layer 3 protocol. That is used to encapsulate the traffic between multiple sites. So what is the protocol number of GRE? Even they should hear. Tell me correct. 47.
47.
Yes. Protocol number is 47. So one downside of GRE is that it doesn't provide you authentication and encryption. So you need to use IPsec in order to provide encryption.
Hey, Chetan, actually, your voice is breaking. I'm not sure it's my issue or.
Everybody is facing the same issue.
Yes, sir.
1 minute. Let me check. Now it will be fine. So it's connected to third floor. Okay. So now. So this we all discussed yesterday. Then we discussed about site-to-site VPN as well. So now we'll see the disadvantage of site-to-site VPN. So why we moved on to DMVPN. So if we talk about site-to-site VPN, let's consider we have 3 sites. This is headquarters, site 1, we have site 2, and we have site 3. So in order for each and every site to communicate, how many tunnels we need? We need full mesh kind of tunnels. So it will be n into n minus 1 by 2. So it will be 4 into 3. So we need 6 tunnels. So if we have 10 sites, then we need 45 tunnels. As the sites goes on increasing, so you need to create multiple tunnels on a particular router. So this was a major disadvantage. That's why we moved on to DMVPN. So if you talk about DMVPN, DMVPN stands for Dynamic Multi-Point Virtual Private Network. Dynamic Multi-Point Virtual Private Network. So what do you mean by DMVPN? So it is a routing technique that is used to build VPN tunnels without configuring statically on each and every set. First point. Second point, so we normally call DMVPN as hub and spoke topology. And you can use IPsec to provide the encryption. So if you talk about DMVPN has three phases. So we have DMVPN phase 1. We have DMVPN phase 2. We have DMVPN phase 3. So before looking at these DMVPN phases, first we'll study about DMVPN components. We have DMVPN components. So the first component in DMVPN is MGR, multi-point GR. Second, we have NHRP. Is next hop resolution protocol. And third part is about routing. So for routing point, you can use RIP, EIGRP, OSPF, BGP, etc. So fourth component is IPsec. So it is not required to establish the DMVPN tunnels, but recommended in order to provide the security.
Okay, so basically, we don't need an IPsec suite for creating the DMVPN tunnel and
we don't require.
sending the traffic to, right?
Yes,
If it's really needed, the authentication and encryption.
for security purpose.
Okay, sure.
Then now we'll talk about multi-point GRE. Yes, you are right, Ganesh. So what do you mean by multi-point GRE? So let us consider we have R1. So we have ISP. We have R2. We have R3. We have R4, and we have R5. So let us consider our company requirement. This is the hub. We have spoke 1. We have spoke 2. We have spoke 3. And we have spoke 4. So the first requirement of the company is, so your hub should have a tunnel to each and every site. So second requirement, so we need to have direct spoke to spoke communication between spoke 1 and spoke 2. That means we need to establish a tunnel spoke 1 and spoke 2. And the third requirement, we need to establish a tunnel between spoke 3 and spoke 4. Now, how many tunnels required according to point or site to site? So from R1 to R2, we have one tunnel. R1 to R3, we have one tunnel. R1 to R4, we have one more tunnel. R1 to R5, we have one more tunnel. Means 4 tunnels on the hub. And what is the second requirement? Establish a tunnel between site 1 and site 2. That is, sorry, not site 1, it is spoke 1 and spoke 2. So we need one more tunnel here. So now R2, one tunnel, and R3, one tunnel. Sorry, R2, 1 plus 1. So you are forming with the hub as well and spoke as well. So we have 2 tunnels here, and we have 2 tunnels here. What about spoke 3? Again, 2 tunnels. So we need to create multiple tunnels. This was a major disadvantage in site-to-site VPN. So what DM VPN does is multi-point GRE. So what we mean multi-point is, we will be only configuring tunnel source and will not be configuring our tunnel destination. Means my diagram is not good. Like this it looks. MGRE means we'll be only specifying our tunnel source, but tunnel destination will be configuring as multi-point. So now the advantage is they will directly form spoke to spoke tunnel. We will not be forming any manual tunnels here. With the help of DM VPN, they will form direct spoke to spoke tunnels. So on the R1, R2, R3, R4, and R5, you need to create the static tunnel configuration towards the hub only. This spoke to spoke tunnels will be automatically established with the help of multi-point GRE. Clear? Any doubts? No. Now. But our requirement is not, company is not saying to do that. So you can do, but according to my requirement.
Automatically it will,
Yes, they will. But my requirement is, again, you need to configure, they will not automatically form. You need to add the command, then only they will form the adjacency. Clear? Now,
Chetan?
yes, tell me.
Okay, so from R1 to all the spokes, we will create a manual tunnel.
Mhm.
And as per our requirement, we need a tunnel between R2 and R3 and R4 and R5.
Mhm.
So we are adding some kind of configuration between those
Yes.
two,
Yes.
right?
Yes.
Okay.
I'll come back to that. Once you see the configuration, you'll understand. Clear?
Yeah, thanks.
Okay. Now, so what is the next component? NHR. So now why we require this? Let us consider small topology. So it is connected to ISP, then we need a public IP. Let us consider 1.1.1.1. So R2 IP is R2 IP has 2.2.2.2 and R3's IP has 3.3.3.3. And we have a tunnel as well. Again, the diagram. So the IP will be 172.16.123.0/24. This is dot one, this is dot two, and this is dot three. Now the problem. So earlier what we were doing, we will be specifying our tunnel destination, but in MGRE, you don't know what your tunnel destination is. Now, how you will find the tunnel destination? Let us consider R2 wants to ping to R3. So if we talk about the outer header, so the outer header is 2.2.2.2. What is the inner header? I don't know. So GRE, since we have manually configured the tunnel, so we know the tunnel IP. That is 172.16.123.2. One 16.123. This is the source, destination. This is the source. This is the destination. Now the problem is we don't know the destination. Correct? Because we will be only specifying our source, not the destination. So now in order to resolve this destination, we use the protocol called NHRP, Next Hop Resolution Protocol. So now what your spokes will do is spokes will register themselves to the hub. So if we talk about NHRP, in NHRP we have NHRP server. We have one NHRP server and others will be NHRP clients.
We need a command to configure that, or
Yes. There is a command. We'll come back to the comments.
Okay.
First understand the process, we'll come back to the comments. Okay.
Yeah, sure.
Okay. So we have NHRP clients. Now, so your spokes with the help of NHRP registration process, they will automatically register to the hub, that is your NHRP server. And your hub will maintain a cache, that is your NHRP cache, and he will be having the entries of your NBMA. So in order to reach to 172.16.123.2, I should use the public IP as 2.2.2.2. And in order to reach 172.16.123.3, I need to use the public IP as 3.3.3.3. This is your NHRP cache. So from the spokes, there will be a resolution request towards the hub, and from R3 also resolution request, and from R1 there will be a resolution reply that we'll be seeing in Wireshark. So these spokes will register towards your NHRP server, that is your hub. So it will maintain a cache. Now as soon as the request comes, let us consider now R2 wants to reach to R3. So we know the source, we know the destination. Now R2 will send the request to the hub, since he knows what is the public IP of what is say R3, that is 3.3.3.3. He will send the resolution reply with the IP address of 3.3.3.3, and he will fill the destination IP. Then these two spokes will be able to communicate with the help of NHR. Clear? Any doubts? Yes, tell me.
For this one, actually, we need a proper routing first, right? I mean, the reachability should be there. Right?
Reachability must be there. Same.
Okay.
Your underlay and overlay.
Okay. And for this NHRP cache,
We'll be using commands.
Is there any kind of cache timing or something? I mean, after some time, this cache will be clear.
We'll talk about that. I will show you in the lab.
Okay.
I hope this is clear. The cache is only in the server and client also will have. Both will maintain. Here we will be having static entries. Here we will be having dynamic entries, because your spoke will register towards the hub. So we'll be statically configuring the mapping on the spokes, and they will register to your hub. Clear? So now we'll talk about phase one. So in DMVPN phase one, so on the hub, we'll be creating multi-point GRE, and on the spokes, we'll be creating point-to-point. So in DMVPN phase one, we don't have direct communication between spokes. Means always your traffic goes via the hub. You don't have direct spoke to spoke communication. So multi-point GR means we'll be just specifying our tunnel source, and we will not be specifying any tunnel destination. And you need to use the mode as multi-point. No. So we'll be doing this lab. So we have R1. So this is your hub, spoke 1 and spoke 2. So this will be 192.168.12.0/24. So let us consider R 14.0. This will be 192.168.24.0. And this will be 192.168.34.0/24. And tunnel IP will be using as 172.16.123.0/24. So on R1, the tunnel IP will be 172.16.123.1/24. On R2, the tunnel IP will be 172.16.123.2/24. And on R3, the tunnel IP will be 172.16.123.3/24. And first, we'll be using the routing protocol EIGRP, and then same we will see with the help of OSP. So BGP we'll use in DMVPN phase 2. Yep.
Chetan, is it a mandatory protocol BGP in DMVP in phase 2, or we can use it?
No. You can use in phase 1 as well.
Okay. I mean, in phase 2, can we use OSP for EIGRP or only BGP?
Yes, you can use EIGRP, OSP for BGP, any routing protocol.
Only, okay.
Done? No. Let's proceed to the lab. So we'll take 4 routes. So the IP address between R1 and R4. /20. So the IP address between R2 and R4 will be 24.0. Between R3 and R4 will be 192.168.34.0. And the tunnel slash on R1 using the tunnel IP as 16.1. So first we'll provide the reachability to the underlay network. So then we'll use a routing protocol for the overlay. So on every site, we have a loop back. So on R1, we have 1.1.1.1/32. So on R2, we have 2.2.2.2. And on R3, we have a loop back 3.0.3.3. Now, so on R1, so it will be R1. Interface is 0/0. So the IP address will be 192.168.14.1/20. We're having a default route towards the ISP. That is your R4. So next hop will be 192.168.14.4. This is on R1. So on R2, so Z0/0 will be 14.4. Z0/1 will be 192.168.24.4/20. Z0/2 IP address 192.168.34.4. We don't require a default route here on the ISP. Sorry, we'll change it.
That's not for configuration.
Yes, right. So okay, 14.4, 24.4, and 34.4. So on R2, so Z0/0 will be 192.168.24.2. IPs you are understanding, right? Shall I write the IPs as well? And we have a default route towards 24.4. .4. I'll write the IP address as well. For all the interfaces, please plot. So okay, so finally on March. So interface is 0/0. So the IP address will be 192.168.34.3. We have a default route towards the ISP, that is 34.4. Done. Let me copy paste. Reduce it. Copy paste. So now go. Not two. Not three. And finally, so check the reachability from R2. So until it should be working fine. 192.168.34. Would reach. So first you need to configure your underlay. So underlay reachability should be. Now we'll configure the tunnel on R1, R2, and R3. So interface tunnel 0. Enter. Provide the IP address. It's 172.123.1/20. So you need to specify the tunnel source. So tunnel source can be either exit interface or the NBME IP of the G0/0. That is 192.168.14.1. Enter. Now we'll not be mentioning any tunnel destination here. So on the hub, we'll be creating MGRE. So by default, the tunnel mode is point to point. So you need to configure it as multi-point. That is tunnel mode, GRE, question mark here. So by default, your GRE IP is present, that is point to point. Now I need to mention it as multi-point. Not visible? Way to do it, save, change settings. Where? 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 Inside? Font? Too much good. Okay. One more command you need to mention is IP NHRP network ID. So what do you mean by network ID? Let us consider we have two DMVPN networks. So let us consider one more. It is R8 on. So we have R6 and we have R7. So this is the hub, spoke and spoke. So in order to differentiate between two different DMVPN tunnels, we will configure the network ID. So this is one DMVPN network and this is another DMVPN network. So in order to differentiate between two different DMVPN networks, we use the concept of network ID. So it is locally significant. So you can use any number for network ID, but just to identify they are in a single DMVPN network, we'll configure the network ID as the same on R1, R2, and R3. It will be helpful for your troubleshooting. Clear? Now. So the next command will be IP NHRP map multicast dynamic. So this command we use to enable the multicast capability. So our routing protocols use multicast, right? If we talk about EHRP, it uses 224.0.0.10, and your OSPF will use 224.0.0.5 and 224.0.0.6. So in order to enable the multicast capability on the hub, we use the configuration IP NHRP map multicast dynamic. Means your spokes will dynamically register with the hub. Clear? So this is the configuration you'll be doing on. So we'll be specifying the IP address. So tunnel source, we are not specifying any tunnel destination here because we are configuring multi-point GR. Then network ID is to differentiate your DMVPN networks, and then map multicast dynamic. So copy paste this configuration. Note that.
Chetan, for this multi NHRP network ID, right?
Network
So we do have, let's say, we do have more than one tunnels. In that case, we use different network ID.
Not just what is identify your DMVPN, what is say DMVPN inside a single network.
Okay.
Use this network ID. Clear?
Yeah. It's just for the identification purpose.
Identification purpose, yes. And it is locally significant. You can use any number on the tunnel. But just to troubleshoot it easily, in order to find all the routers are in the same DMVPN network, we will use this number identical on all the routers.
Okay. Okay.
Clear?
Yeah. Good.
Any doubts? Not decimal value. Number. Any other doubts? Okay. So now we'll proceed to our spokes. So on spokes, since it is DMVPN phase 1, you'll be configuring point to point. Interface, tunnel 0. So IP address will be 172.16.123.2/24. You need to specify the tunnel source. What is the tunnel source? You can use either exit interface or the NBMA IP. Sorry. So where is okay. So interface tunnel 0. So IP address will be 172.16.123.2/20. So you need to specify the tunnel source as the exit interface, G0/0 or the NBMA IP, and tunnel destination as well, because it is DMVPN phase 1. So what is the tunnel destination? It will be your hubs NBMA IP, that is 192.168.14.1. What is the mode? Mode will be tunnel mode GRE IP only, because we are specifying our tunnel destination. Clear? Now, IP NHRP network. So we'll use 123. Now you need to statically map using the command IP NHRP map. So here, first you need to specify your hub's logical IP 172.16.123.1 with 192.168.14. So this is your hub's logical IP, and this is your hub's NBMA. You need to statically map on the spokes. Clear? Now, next command is IP NHRP map multicast. So where you need to enable the multicast address, either on the NBMA or the logical. Where will be forming your adjacency? On the NBMA, right? He needs to send the multicast address through this interface. So you need to specify the NBMA IP of the hub. That is 192.168.14.1. Hub. Where you need to send the multicast to? Hub, right? Yes. Enter. Now the final command. IP, NHRP, NHS. You need to tell who is my next hop server. It will be the logical IP of your hub. That is 172.16.123.1. Run interface. So you need to specify the IP address. Since it is a DMVPN phase 1, so we will be specifying our tunnel source and tunnel destination. And the tunnel mode is GRE IP. So you need to specify the static mappings, that is IP NHRP map. This will be your hub's logical IP to your hub's NBMA IP. And this multicast will enable on the NBMA IP of your hub, because it needs to send the multicast address towards the hub's NBMA IP. Then you need to specify your next hop server. That is 172.16.123.2. Any doubts? No? Okay. Tell me the R3 configuration. So, okay. So let me remove this. So IP address will be 172.16.123.3/20. We need to specify the tunnel source. So what is the tunnel source? It's the exit interface, that is Z0/0 or the NBMA IP of R3. Whatever the tunnel destination, again is your hub. That is 192.168.14.1. Tunnel mode GRE IP. That is by default. Tunnel mode GRE IP. When you're using point-to-point tunnel, this is your tunnel mode. Clear? Next. So IP NHRP network ID 123. Now you need to statically use the map command, that is IP NHRP map. First will be your hub's logical IP, that is 172.16.123.1, and hub's NBMA IP, that is 192.168.14.1. Enter. So IP NHRP map multicast. So you need to use the hub's NBMA IP, and you need to tell who is the next hop server. IP NHRP NHS, that is 172.16.123.1.
So it's basically the same configuration of R3, right?
Yes.
I mean R2.
Just you need to change your IP address.
Tunnel IP
Yes,
address.
yes. Exactly the same configuration. Because you are registering towards the hub, right?
Yeah.
Sure. On R2 as well. Okay, now. So we'll capture the Wireshark on R1. So go to NHR.
The tunnel mode GRE IP, that command is not showing in Shoran, right?
So it will not show that. So that is the by default mode.
Okay.
So go to R2 and initiate a ping. So ping to 3.0.0.3. Will it ping? No, why?
Jumbo. Achram vichadi, phone vichadi.
We didn't create any loopback. So if you create loopback also, it will pay. Let us create a loopback. IP address will be 2.2.2.2/32. So on the R1, IP address will be 1.1.1.1.
Chetan, just one more thing.
Yes, and
Yeah, as you said, the tunnel mode GRE IP is a default by default.
Mhm.
So it's not mandatory to give, right?
it's not mandatory
automatic-
to give.
Okay,
But
we'll
in order
automatically.
for the remembrance of the command, you can just type.
Okay,
Okay.
thanks.
So we'll create a loopback. /32. Now will I be able to pick? No reachability. So you need to use EIGRP. So we'll be using EIGRP for overlay. Let us enable EIGRP over the tunnel. So router EIGRP 123. Use the network 172.16.123.0. Network 1.1.1. And no automatic summary. So go to R2. Enable EIGRP. Router EIGRP 123. Network 172.16.123.0. 2.2.2. Go to R3 and enable the EIGRP. Router EIGRP 123. Network 172.16.123.0. Network 3.3.3. Now will I be able to ping? So go to R2. Ping 3.3. Why? I have the entries on R1. So if you go and check on R1, show IP route, EIGRP. Can you see? I have the entry for 2.2.2.2 and 3.0. I am unable to pay. So you need to tell me I am unable to pay. So before that, just check the registration request and registration reply. Wow. Tell me I am unable to pay. So go and check the R2's routing table. Show IP route. Yes. I have entry 1.1.1. I have the reachability, right? Because the hub knows. Can you see? I have 2.2.2.2 and 3.0. Formation to spokes. Why? Yes. It's EIGRP problem. R1 is getting both the networks. That is 2.2. But why I'm unable to see on why R1 is not sending to R2 and R3.
Split horizon, right?
Split horizon. Good. So if we talk about EIGRP, split horizon is by default enabled. So you need to go to R1 and disable the split horizon. Became too much big. So just disable split horizon. So interface tunnel 0. So no IP split horizon. And you need to specify EIGRP and auto. Otherwise it will enable for RIP. Enter. Now if you go and check on R2 and R3, so they will have the entries. But in DMVPN phase 1, always your traffic will go via the hub. So if we trace 3.3.3.3 numeric, it's going to hub and reaching to the spoke. There is no direct spoke to spoke communication in DMVPN phase 1. Clear? So one key point to remember, split horizon. what do you mean by split horizon? Yes. Tell me, what do you mean by split horizon?
It won't send that update packet from where it received.
Okay. What do you mean by that? Yes. What do you mean by split horizon? ERP?
Loop prevention.
Loop prevention. Okay. So I'm asking, what do you mean by split horizon? So what do you mean by split horizon is the interface on which I receive the prefix. I will not advertise that prefix from the same interface to another route. That is split horizon. So if we don't disable your split horizon on the hub will never advertise the network of R2 to R3, and R3 will never advertise it to R2. So you need to go to interface tunnel 0 and you need to disable the split horizon. Clear? 1 minute. I'm not getting the NHRP resolution. Let me shut down the tunnels and re-enable that. Interface tunnel 0. R2. Now it is coming. Registration request. Can you see here? So 1 minute. Let me minimize this. So now, so both the spokes are registering towards the hub. Can you see the registration request here? So it is from 34.3 to 14.1. So this is 34.3 is the IP of R3. So R3 is registering himself to the hub. He's sending a registration request and hub is sending a registration reply. In the same way, even what to say another IP that is 24.2 sending a request and a registration. So in the request, if you go and check NHRP, go to mandatory report. Can you see here? So what it is saying, what is the NBMA IP? He needs to register, that is 24.2. Sorry, 24.2. So what is the logical IP? 123.2. That's why R1 will have an entry in its NHRP cache. Now, if you go and check the NHRP cache of R1, show IP NHRP. Can you see? I have two entries. One is, so 24.2 is the NBMA IP and he is registering with the logical IP of 172.16.123.2. So in the same way, 192.168.34.3 is registering with the logical IP of 123.3. Clear? So we talk about show DM VPN. So
Then,
yes, tell me.
okay, let's say after 2 hours, we change that, or before 2 hours, we change the R2 exit interface IP. Let's say, then it will automatically.
Yes, you need to shut and no shut once.
Okay, we need to give shut and no shut, right?
Yes,
if we change the IP.
Yes, yes.
Okay. Yeah.
So can you see on the hub, it is dynamically creating the entries because we didn't specify any NHRP map command, right? So if we talk about spokes, spokes will create a static entry. Show DMVPN. Can you see? I have one static entry, that is yes. Because we will be statically mapping on our spokes. Clear? And you'll be having NHRP of the hub. So any doubts till here? Any doubts?
No, good.
Clear? Now, this is about EHR. So now we have a problem with OSPF. Now, as soon as we enable OSPF, so on the hub. We'll remove EHRP. So no router, EHRP 120. What is this box? Before this, can you tell me the network types of OSPF? What are the network types?
Point to point, point to multi-point, NBMA, BMA.
OSPF network types. So we have PMA,
NBMA,
we have NBMA,
point
we
to
have
point,
point to point,
point to multi-point,
we have point to multi-point,
point to
broadcast,
multi and non-broadcast.
and point to multi-point non-broadcast. So now we'll try each and every one. So first we'll form BMA, then we'll make the network type as NBMA, then point to multi-point broadcast, and point to multi-point non-broadcast. Now, first we'll go and enable OSPF. So go to R1 and enable the OSPF. So router OSPF 1. Network 172.16.123.0. So to specify the subnet mask or wildcard mask. Wildcard mask .255 and area 0. Enter. You need to enable your loop back as well. Go to R2 and R3 and enable the OSP. .172 16.123.0 area 0 on the loop back as well. Area 0. Go to R3 and enable the OSP. Network 16.123.0 area 0 and on the loop back as well. So now go and check on R1. Can you see why it is flapping? Because by default OSPF will treat the network type as point to point. No logging consent. Let me disable this. Check show IP OSPF interface G0/0. Can you see the network type here? Point. What do you mean point to point? So it can have only one adjacency, right? Either with R2 or either with R3. That's why your neighborship is flapping. So one key point to remember in OSPF, you can't use the network type as point to point. Please make a note. So if you are using OSPF in DMVPN, you can't use point to point network. Otherwise, your DMVPN neighbor table will be flapping. A routing table will be flat. Not understanding anything? Understanding.
Chetan, just a
Yes.
doubt.
Tell me.
Okay, let's just forget about the DM VPN. I have a hub and spoke technology. And if I run OSPF between R1 and R2 and R3, and by default, the network type will be point to point, right?
Correct.
Will the adjacency form? No.
So that's why it is flapping, right? It will not form. You tell me on one interface how it can form neighborship with R2 as well as R3 as well.
Okay.
It can't form, right? So it can form either with R2 or with R3. That's how what it is doing. It is forming with R2, then it is again breaking, then it is forming with R2. So that
Okay.
was
Okay.
clear.
Yeah. Clear. Clear. Ji.
Now how to change the network type?
In interface, I believe.
What is the command?
IP/OSPF network type, something like that.
Right.
But that's-
So go to the tunnel and change the network. IP/OSPF network. Can you see? We have broadcast, we have non-broadcast, we have point to multi-point broadcast, and we have point to multi-point non-broadcast as well. And we have point to point. Let us change it to broadcast. So go to R2. So interface tunnel 0. IP/OSPF network broadcast. Go to R3. So interface tunnel 0. IP/OSPF network broadcast. So will DR/BDR election happens in broadcast? Do you have DR/BDR election?
Yes.
So what about timer? What are the hello and hold on timer in BMA?
It's 10 and 40.
10 and 40. Okay. So now, so one more problem is, so since it elects a DR/BDR election on each and every segment, right? So the problem is your spokes should never participate in the DR/BDR election. How to do that? You should set the priority as 0. So to go to the spokes and set the priority as 0.
Why we need to do that? I mean, why we avoid?
Because
spoke?
it doesn't make sense, right? So let us consider R2 has become the DR.
Okay.
It will not, what to say, it will not affect your traffic or something like that. But if you talk about hub and spoke, so hub should always be your DR. So these two should never participate in the election. It will form a problem with the stub. When you create stub or totally stub, no, that time it will create a problem. So always they tell these spokes should not participate in the DR/BDR election. Clear? So you need to set the priority on the spokes.
Okay.
Clear? Okay. So to go to interface tunnel 0 and set the priority as 0. IP/OSPF priority 0. Go to R3 as well. So IP/OSPF priority. Now go to the hub. Console. Show IP/OSPF interface tunnel 0. Now I have changed the network type to broadcast. State is DR and priority by default priority. Can you see the timers here? Hello is 10 and dead is 40. Talk about show IP/OSPF. Can you see? Your spokes are DR others. And they must be DR other only. Clear? Now go to R2. Do we need split horizon here? So can you see who is the DR? Your hub has become the DR. Even on the R3 as well. Show IP. Clear? And if you trace from R2, again 2 hops. Why? Because phase 1. So it will always go via the hub and hub will send to the another spot. That's why we are seeing 2 hops. So anybody has any doubts still here? It's clear?
Yeah.
Okay, now we'll change the network type to non-broadcast. Go to R1. So interface tunnel 0. IP/OSPF network, non-broadcast. Go to R2. Why the neighborship is down? Yes.
Network type is different.
Yes. Network type must match in order for the OSPF adjacency. So to go to R2 and R3, change it there. Network type. Interface channel 0, IP OSPF, network, non-broadcast. So one more issue here, you need to troubleshoot that. They will not form the neighborship. Why? So interface channel 0, IP OSPF, network, non-broadcast. Check the neighborship, show IP OSPF neighbor. Why? Non-broadcast, no hello packet. This is a network type, right? No. Data is 30 and 120. If you check show IP OSPF interface, tunnel 0. So what is the network type here? Network type is non-broadcast. This is there. Can you see hello and hold? This is same on all the routers. If you talk about R1 as well, go and check on R1. Show IP OSPF interface tunnel 0. Timers is same. Why they are not forming the adjacency? Network type is same. Timers is same. Why they are not forming the adjacency? Check show IP OSPF neighbor. I don't have any adjacency. Why? Routing. Why? Because in non-broadcast, you need to use a manual neighbor command.
Yeah.
They will not automatically form the neighborship. So you need to go to R1, go under the OSPF process, and to specify the neighbor command. Go to R1. So router OSPF 1 is neighbor. Who is your neighbor? Yes.
Should be tunnel.
Tunnel. It should be tunnel. You're forming OSPF adjacency on the tunnel, right? So you need to specify the tunnel. 172.16.123.2 neighbor. 172.16.123.3. So go to R2 and R3. Can you see they have formed the adjacency? To go to R2 and R3, you need to specify as well. Go to router.
Hey, Chetan.
Yes, tell me.
Yeah, can I just show now in R2? I mean, the OSPF is.
Adjacency you're talking about?
Yeah. Okay. So do we? It's really mandatory to give neighbor command here too?
No. But
Okay.
just for remembrance, give on R2 and R3 as well.
Okay.
Specify the neighbor.
I just want to know that.
Router OSPF 1 neighbor 172.16.123.1. Go to R3 and specify the neighbor. Now, if you check the OSPF adjacency on R1, show IP, two adjacencies. If you trace from R2, even I have reachability as well. This is about non-broadcast. So next network type is point to multi-point broadcast. Now we'll change point to multi-point. So interface channel 0. So IP OSPF network type point to multi-point, enter. Or if you want to specify non-broadcast, you need to specify the keyword. Point to multi-point will by default enabled for broadcast. Again, the adjacency is down because network type must match on the hubs and on the spoke as well. So go to the interface channel 0. So IP OSPF network point to multi-point. Go to R3. Press channel 0. IP OSPF network 0.2 multiple. So go to R1 and check the adjacency. What is the hello and hold on time in point to multi-point? Show IP OSPF. So there is no DRB relation in point to multi-point. Show IP OSPF interface channel 0. So this is point to multi-point broadcast. Can you see the timers 30 and 120, and they are dynamically forming the neighborship. Means we don't require any neighbor command. So just go to OSPF1 and disable the neighbor. No neighbor 172.16.123.2 and 123.3. The same way, go to R2, disable the neighbor command. Router OSPF1, no neighbor 172.16.123.1 and on the R3 as well. Show IP OSPF able to form without the neighbor command. Clear? So go to R2 and trace. So final network type point to multi-point non-broadcast. OSPF network point to multi-point non-broadcast. So go to R2 and R3, change the network. Press channel 0. IP OSPF network point to multi-point non-broadcast and on the R3 as well. Non-broadcast. What are the timers? Again, it will be 30 and 120. Will they form the adjacency? Yes or no? Show IP
No.
OSPF 1.5 section OSPF. They should not form the adjacency. OSPF. So still it is enabled in point to multi-point broadcast. 5 section. Didn't enable for non-broadcast. They should not form the adjacency. Section. This is strange. Show IP OSPF. It should not form for non-broadcast. So let me disable OSPF. No router. So go to R2. The OSPF process. So go to R3. Remove the OSPF process. Router. Just recreate the OSPF and change the network type to router OSPF1 network 172.16.123.0 55 area 0.1.1.1. Go to R2. Go to R3 router OSPF1. Yes. Go to R2 as well. Change the auto OSPF1. 0. And on the loop back as well. Interface. So now to let me share this. This. Go to interface from zero. Enable the network type. Point to multi-point non-broadcast. Should not form the adjacency. So go to R2. Just no shit. IP, OSP. There is no neighborship. There was a bug. That's why the adjacency was. Can you see? There is no neighborship with non-broadcast. So you need to use manual neighbor command. Go to the router. Your phone. So neighbor 172.16.123.2 and 123.2. So router 172.16.123.1. See, they are forming the adjacency. Go to R2 as well. 172.16.123.1. R2 adjacency. Show IP OSP neighbor. Show IP OSP interface. Answer. It's not showing non-broadcast, but the type is non-broadcast. So hello 100 timer. I need to use a manual neighbor command. So anybody has any doubts? Yes, or everything gone above top of the head? I see so many faces going everything top of the head, right? Yes, tell me.
It's still showing point to multi-point, right? It's not showing.
Multi-point. It should show non-broadcast. If you check shore and pipe section OSP,
it will show.
yes. Can you see here? I enabled point to multi-point non-broadcast.
Yeah.
There is a bug in image. Clear?
Yeah. Good.
Is any doubts?
No, Chetan. Good.
Okay, guys. So today we'll end up. We'll continue tomorrow.
Yep. Thank you, Chetan. Thank you.
Thank you. Bye, guys. Have a nice day.
Bye. Have a good day all.